This video is going to pick up where 7.2's first video left off. Um, Talking about similarity. This is as determine whether each pair of figures is similar. Remember when we talked about similarity, basically we're saying is that if you have two polygons in which all the corresponding angles are congruent and all the sides are proportional, then your figures are similar. There's going to be eventually some um, theorems that allow us to condense that a little bit, especially for triangles. But right now, basically, what we've got to figure out is if these are going to be similar, then angle A, which is a 30-degree angle, needs to match up to angle D, which is also 30 degrees. So we got those two angles congruent. That's good. I'm going to go to the right angle, which would be C here. And then the right angle over here would be F. Then obviously, then that would leave me with B and E. So the question is, are these similar? Okay. If they're going to be similar, we need angles congruent to angles. So we need angle A congruent to angle D. We have that. We need angle C congruent to angle F. We have that. And then by the third angles theorem, which says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. That is confirmed. So we got the angle component. Now we need to make sure that corresponding sides are proportional. And that means the AC is going to correspond to DF. That ratio needs to be exactly the same as that of when CB is compared to FE, which then is the same as BA compared to ED. Okay, if we can, we've already got this to be true. Okay, so what that tells us is same shape. Okay, that says that they're going to be all triangles or whatever the shape might be. Okay, all quadrilaterals, all pentagons, whatever. So in this case, both figures are triangles. This, if we can show this to be true, it'll be same shape, different size. Okay, but we can't just say different. It will be proportional size. And that then is the conclusion that, or allows us to make the conclusion that these two shapes would be similar. So I'm going to just pluck off these values. So 6 radical 3. That's AC. Now I'm going to find DF. So D to F is 4.5 radical 3. Does that equal CB, which is 6, over FE, which is 4.5? Does that then equal BA, which is 12, over ED, which is 9? Okay. So there's a couple of different routes you can go here. If you don't know the simplification or whatever, you could take your calculator, type these in, put them all in decimal format. Okay, put them all in decimal format. You're going to find out that you get 1 point, if I do this, 1.3 repeating for all of these. Okay. If you understand the reduction, which I hope we do, this radical 3 and that radical 3 can cancel. So it leaves me 6 over 4.5 equals 6 over 4.5 equals 12 over 9. Okay? Obviously, we can see that those two are equal. But that doesn't mean that maybe those two are equal. Or those two are equal. Okay? So we have to make that comparison. Is 6 over 4.5 the same as 12 over 9? We can do one of two things. You can either multiply this by 2 over 2, I multiply that by 2 over 2, which would give me a multiplication of 1, which doesn't change its quantity. It'd give me 12 over 9. So that would be indeed equal. Or I could take this one and divide the top by 2, bottom by 2, and give me 6 over 4.5. However, that's not always the easiest thing to do. It's not always easy to see, what can I divide this one by to give me that numerator and this denominator to give me that denominator. But what we can do is we say, oh, I can cross multiply there. I know 6 times 9 is 54. I can cross multiply there. You might not know 4.5 times 12, but you should know 4 times 12 is 48. And half times 12 is 6. And 48 plus 6 is 54. So now you get that these are proportional because they have cross products that are equal. So even though initially when we write down these three ratios, this is an extended ratio, they don't look the same because they're not, 4/3 to 4/3 to 4/3. But once we do reduction, they are exactly that, 4/3 to 4/3 to 4/3. So these would be similar figures because corresponding angles are congruent and corresponding sides are proportional. All right, so we come down here. We want to see if we can do the same thing. So I'm just going to go from, let's name this A, B, C, D on the left, and see if that is similar to E, F, G, H. Okay. The way I've named these is just to make sure that when I go A, B, that's the largest side over here. And it's going to compare then to one of the largest sides over there. And then when I compare the next group, BC, that's the smallest side over here, does that compare to the next smallest side? So I'm comparing essentially corresponding sides here. Obviously, you can see that all the angles are going to be right angles, so they're all going to match. But now we need to see, does AB compared to EF, is that the same thing as BC compared to FG? Is that the same thing then as CD compared to GH? And then DA compared to HE. So because it's quadrilateral, you now have a longer extended ratio, and you have to show all four of these ratios to be the same. Once you find maybe one of them to be different than the others, then you have a contradiction of similarity, and therefore the figures would not be similar. So if I look at these, let's say 7 compared to 6, A, B to EF. Is that the same thing as BC, which is 6, compared to FG, which is 5? And right here, I can keep going, okay? But right here, I get a cross product of 35 and a cross product of 36, and those are not equal. So these are not equal. Okay, this is not a true extended ratio. So if that's the case, these are not similar quadrilaterals. Basically meaning not all rectangles. If I have two rectangles, they're not similar. They don't necessarily have to be similar. Here's another example. It says write a similarity statement, then find x, y, and ut. Some people try to do this without the similarity statement. I think that is just a plan for failure right there. What I'm going to do is I'm going to name this first. We got Pentagon here. I'm going to start with letter R, and we're going to travel. Let's go to. So we start at 1, and we're going to go to 2. So R to S. Get a larger pen here. So we go R to S, and we should go follow around to T, to U, and we'll finish at V. Okay. Similar to A, to B, to C, to D, to E. Okay. Now, I should probably, in the directions, probably say these two figures are similar, write a similarity statement, find x and y. So now all I'm going to do is I'm going to write and this gets easier as the number of sides start to be reduced in our problems. Traditionally, we'll have like three because that's going to give us two triangles, and that's what we're most interested in. But I'm going to say RS to AB. So I'm going to have five extended ratios here. ST to BC. TU to CD. UV to DE. And then VR to EA. And like I said, some people don't want to do this, but it's so much easier to do this, especially when your figures are rotated or flipped or reflected. I don't think I have too many images that way. This one down here and this one here might be that way, but these are reflected images here, rotated images, and it's not as easy just to say, left, 18 is going to compare to 4, and y plus 2 is going to compare to 5. Okay, these are kind of a one-to-one, just a transformation, a slide. If you remember that from eighth or seventh grade math, you can get yourself in a lot of trouble if you with this type of work if you don't write that. Here's the thing: I'd rather spend the 15 seconds of writing that so that then I automatically know RS and AB. I don't have distances for those. So I'm just going to kind of cross that out. ST, I know to be 18. BC, I now know to be 4. And automatically, right away, and it won't always be right away, but I get now a ratio that is numerator and denominator are both numerical. That's my scale factor. Okay, we talk about scale factors being reduced. 9 over 2 would be the actual scale factor. Okay, but I'm going to keep going. TU over CD. TU is y plus 2. CD is 5. If I were to leave it like this and not go any further, that at least gives me a way to solve for y. But I can keep going. UV, I don't know UV. I don't know DE. They don't give those, so I'm just going to wipe that one away. The other one that I know is that VR is X and EA is 3. And I like doing it this way because it guarantees, some people get confused, well, does the y plus 2 go up top or does the 5 go up top? Does the 3 go up top or does the x go up? They get these mixed up. But if you do exactly what the definition of similarity tells us to do, you'll never make a mistake. So if I look at these two, and I'm going to, at this point, now I'm going to reduce. So I have 9 halves equals y plus 2 over 5. That gives me an equation to solve for y. Okay? Now, if you have y, when you've got y solved for, you could use those two to solve for x. But I don't, at this juncture, have y. So what I'm going to do, and I think would be easier, regardless of whether I knew y or not, is to look at those two. Because it's extended ratio, so I know 18/4 or 9 halves again. 9 halves should equal x over 3. So now cross multiplying, I get 10, not 10, 9 times 5 is 45. I don't know where 10 is coming from. 45 equals 2y plus 4. So you get 41 equals 2y. Y equals 41 halves. Over here, I get 2x equals 18. Not 18. Man, 27. And then x will equal 27 halves. Now it wants to find ut as well. So then I'm just going to add. So ut would be 41 halves plus 2, which would be 4 halves, so 45 halves. So I'm going to kind of work through the rest of these in the same kind of fashion. Okay, so this one here, obviously this isn't in your notes. If you printed them off, you might have to add these. But I'm looking at H would match up to M. I'm going to go to I. That should match up with N. then down to J and O, finishing at G, and then respectively L. So are those similar? In this problem, we would say we would probably start off with directions that they are similar. Find X, find Y. Okay. So that being the case, when we go through here, we have no side links. No side links are being provided. Okay. So I'm not going to need HI compared to MN, J or IJ compared to NO, JG to OL, and GH to LM. And the reason is because I don't know any of those things, so I wouldn't be able to fill that one in, that one in, that one in, and that one in. But if these two shapes are similar, what do you know about that angle compared to that angle? They should both be 98. Okay. So if they ask us, find Y, well, that's J, which is third letter there. O, third letter there. So Y plus 3, or sorry, Y plus 30 should equal 60. And likewise, then this X minus 4, that better equal 87, because L and G need to match up. Okay, so all that's getting at is if two shapes are similar, then their angles have to be congruent. Here's one dealing with, going back to that kind of that original problem where these sides are, we're going to have to look at the proportional breakdown of the sides here. So starting at angle A, B, C, D. So it went from 1, 2, 3 to 4. So that's going to be similar to F, E, H, G. So we're going to say AB needs compared to FE. BC compares to EH. CD compares to HG. And then AD or DA compares to FG or GF. And this is the type of problem, this is the situation where, a lot of our questions in our homework of Math Excel, the pictures of the images might be like this one on the left here, cut, moved to the right, enlarged or shrunk a little bit. So it'd be really easy for you to realize that those two things should match up. Okay? And that's what we see when we say AB to FE, X plus 2, right underneath X plus 2 matches up to 15. Okay? But if you're not watching these videos, which I know many of us are not, you're going to miss out because on a test or a quiz, I am going to purposely reflect things, rotate, so that you can't just say left to left, bottom to bottom, right to right, top to top, that kind of thing. You'll have to be able to use this to generate this so that you create the correct relationships down here. So BC then is 8, EH is 10, CD is Y minus 3, HG is 5, and then AD, that's another situation where they, we don't put anything there or there, so we don't know that one. But here's my scale factor, 4/5. So I'm going to say X plus 2 over 15 equals 4/5. And then I can do the same thing right there to find Y. So I'll say 4/5 equals Y minus 3 over 5. Okay. Over here on this left-hand side, we'll do this one. We got 60. When I cross multiply those two, and 5x plus 10. Subtract 10. X has to be 10. Not too bad there. This one here, I'm not going to cross multiply because this is actually, it doesn't happen all the time here. This is a rare situation. But because the denominators are the same, this is what we call a one-to-one correspondence. In order for the left-hand side to be the right-hand side, when the denominator is the same, that means the numerators have to be the same. So that's an easier equation. When does 4 equal y minus 3? Well, that's when y is equal to 7. So there we've got those. All right, so this is the type of problem that I would uh, most likely put on a test or a quiz. Um, we have to first identify the triangle on the left, and we'll just call it RTS. RTS. Similar to triangle, so R had 3 marks in it, so you're gonna come over here and find U because that has 3 marks in it. T had 1 mark in it, so I gotta go to V and then W. And now that automatically is going to put things in the right spots for me. When I go RT to UV, I'll go TS compares to VW, and SR is going to compare to WU. And now I know precisely that RT, y plus 3, is going to pair up with UV, which was 21. TS, which is 49, is going to match up with VW, which is 20, and there's my scale factor. And then SR, which is X, going to match up with WU, which is 29. And that makes it so much easier than having to guess, okay, 49, that's between 1 and 2, come over here, 20. It's just so much easier. So cross multiply those. So I'm going to let you do this work. So that'll let you solve for y. And then these two, 49 over 20 is equal to x over 29. That'll allow you to solve for x. So hopefully with those examples, you get a good hang of practicing these similarity statements, practicing the proportional statements, and then plugging things in, substituting to arrive at values for unknown variables.